To really understand what's happening in the human body, aka physiology, there are a few concepts that you need to get to grips with. In this video series, we will be covering the 4 gradients that allow the human body to function: concentration gradients, osmotic gradients, electrochemical gradients, and pressure gradients. Then we will wrap it all up with a discussion on turbulence and how it makes all the sounds that come from your body. First, we need to understand what a gradient is. The easiest way to think of a gradient is a hill. A very shallow hill has a small gradient, whereas a very steep hill has a large gradient. If we have 2 hills with a valley in the middle, and we take a marble and place it somewhere on one hill, I think you will all agree the marble will roll down and come to rest eventually somewhere in the valley, because the marble is trying to find balance or the place of lowest energy. Question: what do you think will happen if we put the same marble on a hill the same length, but that has a steeper gradient? It will roll down to the base faster. The bigger the gradient, the greater the pull towards the place of balance or lowest energy. Did you notice that the faster it rolled down the hill, the further it rolled up the other hill before rolling back down? No matter how shallow the hill is, the marble will always roll a little further or overshoot the place of balance, and needs to adjust a little or a lot in the other direction. This is important for later, so just keep this in mind when thinking about moving down gradients. Now let's think bigger. Now we need to get a cart to the top of a hill. The only way to get it there is to push it up the hill. Question: does pushing the cart up a hill take energy? Yes, of course it does. It's hard work, and the bigger or heavier the cart, the harder the work. So to move something up a hill or up a gradient, we need to use some sort of energy. And as soon as we stop putting that energy into pushing the cart up the hill, it's going to start rolling straight back down again. Now that we understand gradients, there is one more thing to get your head around before we get into specific physiological gradients. Gradients can be used to help us do work. For example, say we had a box filled with apples sitting at the top of the hill, and we wanted to get it to the bottom. A box being square doesn't roll very easily, does it? But if we put the box in the cart, then we could use the energy we had stored in the cart to pull the box down the hill. Remember, we had to use energy to push the cart up the hill, and now that energy is stored in the cart. The cart rolls down the hill, releasing the energy we stored in it, but because the box is inside, it also pulls the box down the hill in the process. So now we have used a gradient to help us achieve some useful work. So what does this have to do with the human body? Well, it's a way for you to visualize what's happening when we start talking about physiological gradients, because we're now going to start talking about things as molecules and ions, which are so tiny you can't see them. And when you can't see them, it can be hard to visualize what's happening.